Hello and welcome back to another lesson of Logos and Letters. Today we are studying chapter 6 about quantities, discrete and continuous. So let's get stuck straight into it. Tu de posu to menesti diorismenon, to de sunukes. So diorismenon, for those who want to learn some Greek, essentially means bounded or defined, but in our modern English translation we would say discrete, to de synekes, and this is continuous. Okay, to synekes. And if you're wondering what these little words here do that I often skip translating, they convey ideas or force and things like that. So you can see here to diorismenon, to synekes, and then they've got men there. So it's like comparing two ideas. So on the one hand, there is SD, there is discrete, and on the other hand, there is continuous. Kai tomen ekthe sine konton prosalela, tonnen autois morion suresteke, to de vug ex ekonton desin. So we'll stop there just for now. So, and there are some that are having position, okay? Position in relation to each other, and their parts morion meet sunesteke within themselves. So within themselves they have these positions in relation to one another, and they have a point of conjunction, of coming together. All right. So let's have a look at some of those examples. So esti de diorismenon men hoion arithmos kai logos. So there are discrete quantities like number and speech. All right, arithmos is number and logos is speech. So there are obviously within those two terms massive amounts, virtually infinite examples to be had. So I'm obviously not going to go through them all. We don't have that time. But a discrete quantity would be like 2 statues. All right. Another discrete quantity, 1 cathedral, 1 arrow. Let's just say 12 roses. Let's say, I'm just guessing here, 9 soldiers. Okay, so they're discrete quantities, and same with speech. Okay, so speech is an interesting one to think about. How is that a discrete quantity? Well, in a few different ways it's a discrete quantity. Think of the amount of think of like how it begins and ends, how you know when it begins and how you know it ends. Okay, but also consider the fact that he's just laid out the rule, okay, here, that they have parts that meet in relation, okay, to one another. So there are parts and they're related to one another, and there's a point where they meet. So when you think of a speech, you know, you can think of even the syllables, the sounds that you make, the phonemes, coming together and meeting at a point, and one ceases to be and another one comes in that moment. So even the words that I'm saying right now, one sound comes and then I sort of, what's the best verb to use here? It comes and gives up its place to the next. It cedes its place. Cedes is probably the best. Not S-E-E-D-S, but C-E-D-E-S. So it cedes its place to the next sound. All right. Sunekes de hoion gramme epiphania soma. So starting backwards here, soma, how is body a continuous quantity? Well, there's no real beginning and end to it. There's no definable beginning and end to it. Okay, there's no like common consensus where a body begins and ends. Okay, so if we're looking at some of the images we're looking at before, Can we truly say that there's any point here on her body where the body begins and ends? No, not really. But even more broadly than that, all bodies. Okay, so where does this body begin and end? There's no definable point. But also, again, come back here. It's this rule again. It doesn't fit this rule. Synekes doesn't fit this rule. Doesn't have within itself parts that meet at a common conjunction. Okay, when it comes to quantity. Okay, we're not talking so much about a physical, actual thing. We're speaking about bodies here. All right, just in general, mathematically. We're really thinking mathematically here. Doesn't really fit this rule, so it's not going to be. If it does fit this rule, it's discrete. Okay, I'm just going to say that. And same with a surface. All right, you look at any surface here. We're standing here, and who knows, maybe we're on the island of Lesbos, and it's a beautiful spring day or whatever it is, and we're looking at all these finely constructed marble, whatever you want to call them, and we can obviously tell that the surfaces don't have within themselves parts that have positions in relation to one another, whereas speech does. Like if you think of speech, it has a beginning, middle, and an end. It has different vowels which come together. It has consonants and vowels which come together, graphemes, phonemes, okay, all that. Any teachers out there will know all about those sorts of things. And same with number, of course. It has parts related to it within itself. I mean, a mathematician might think of factors, and that's a pretty good way, but be careful with that. Just let us get through some more, and we'll speak more about how parts and numbers work, because it's not just so straightforward as there's 5 and 5 or inside 10, or there's 2 and 8 inside 10. Doesn't quite work like that. So just for now, we'll consider that discrete numbers, discrete quantities are things that have a definable beginning and end to it. All right, we know where the number 34 begins and ends. It begins before 35 and so on and so forth. But if you said 34 point something, that's different. That's a continuous number. We're talking about integers here. We're talking about untouched numbers. All right, so there's no like 0.3 reoccurring after it. All right, let's continue on. Etide para tauta chronos kai topos. So, sorry, I should give you those translations there. So, chronos is time, kai topos is place, right? Time has different words in Greek that you can use. You can use words such as, what's another word? Kairos, all right? Kairos is like a moment in time, or a definable moment in time. So, you can talk about the kairos, tu huios tu theou, of the Son of God, okay? And you might just be speaking about his life or his ministry, all right? Jesus' ministry. But chronos is time itself, okay? Just flowing time. Good luck telling people when that definitively begins and ends, okay? Because if you could do that, there's a Nobel Prize coming your way. Topos, place. Of course, place has a definable beginning and end. You can say where any place begins and ends, really. I'm sure some people can think of examples where it doesn't seem so, but we are just going to say that place, location, has a definable beginning and end. Like I know where Australia begins and ends. I know where my home begins and ends. I know where the Harbour Bridge begins and ends, okay? So, ton mengar tu arithmu morion udis esti koinos horos. I'll end the lesson here. This is a beautiful point. This works for everything that we just said. Pros hon synaptai. Yeah, we'll leave it here. So of these things that we're speaking about, on the one hand, of number, there are no parts. that have a common or general point of meeting, horos. So there's no general point where they meet. Okay, so you think of number, and this is what I was saying before, like the number 34. So who's studying here? Who's got this kid, right? So he's reading something. Maybe it's he's got a math textbook here, right? Or maybe a music book, whatever. And he sees the number, thinks of the number 16. And within 16, we can't actually definitively say that there are points where it meets up. Okay? To hold points where something meets up, you sort of have to have a physicality to it. Okay? You sort of have to have you need to be able to physically hold a position. Physically holding a position needs to be done by things that last, that persist. Okay, relates back to this word that we looked at, diamenai, things that continue. Things that don't continue and persist cannot hold a position. They come and go. Okay, so syllables, words that we say, they come and go. Right, they can't hold a position for any longer than a moment. But there are other things which can hold a position. All right, so like a body, obviously, and a surface, all right, and a line, or gramme, a line. Gramme might sound like grammar to some people, and I get where they're coming from that, but gramme means line. Like these are specifically geometrical words that he's using, and he's probably a avid student of Euclid and his works, like the geometer's work. So gramme is a line, and that's continuous. The infinite line is quite a common idea, even in high school and even primary school mathematics sometimes. So there are two big takeaways here, two defining features. We have the first one for bounded numbers, discrete numbers, and they, once again, ekthesin ekonton, having position, prosalela, in relation to one another, ton en autois morion sunesteike, and their parts meet up. This one, ton mengar, of these things spoken about, gar tua rhythmu, of number, morion, parts, udis esti, koinos horos. So there are two defining features. One, they have parts in relation to each other that meet up, and the other, they have parts that do not meet up. Now, they might have parts in relation to one another. So think about time, for example. Time has the past, the present, and future. In relation to each other, like conceptually, yes, those are parts, okay? And we can easily define them and understand them. However, there's no point where they actually touch, where they actually meet up. And in our head, we can define that as the past, where the present meets the future and the past. That's complicated, that's messy, and there's still no definable point, okay? How do you say where exactly one moment begins and ends, okay? Moments come and go. They don't last long enough to actually hold a position, besides conceptually in our head. So those right here are the two major differences between the two. If you've noticed, the philosopher, the Stagirite, is constantly looking for what's unique about each thing that he's talking about. Right? Malista de idion, right? What is particularly unique about substance, theousias. So here he's found what's particularly unique about bounded number, discrete number, is that it has a point where it meets up, its parts meet up. And for unbounded or continuous numbers, they do not have a part which meets up in common, okay? We'll leave it there because it's been quite a dense lesson, even though it's been quite concrete. And let's just take away those 2 points before we continue any further. And that'll be a great place to get a foothold in chapter 6 in this new topic. Chapter 6 is quite long, not as long as chapter 5, but it's packed full of very practical and useful information about number. And obviously number has so much to do with everything that we speak about, even in our common conversation. So having these tools in your tool belt, being able to precisely and clearly think of each type of number as it's spoken about is extraordinarily useful for not just a philosopher or a theologian, but even for an economist, even for a psychiatrist, even for a teacher, even for a police officer, even for a criminal, someone involved in illegal economies, unofficial economies, as some people say. Those people can even benefit from this as well. So this is an extraordinarily universal topic, and I hope you enjoy it as much as I did when I first read it. If you do enjoy it, let me know and tell me why. If you don't enjoy it, let me know and tell me why. Thank you for your time. My name is Liam, and as always, si semper fortis in opere tuo. I'll see you next time.